Okay, how you going, Year 10? Today we're just going to be doing a bit of a review of drawing up probability trees. Now, the reason why we're doing this is because I think this is the key skill in this topic of probability. If you can draw and use probability trees, then you sort of, it encapsulates a lot of the concepts that are in the course. So we're going to just go over this process again, and then you can see the questions there that you can do for practice. Okay, what a probability tree does is it visually shows the different outcomes and probabilities across multiple events. So we show the different outcomes as branching off in different directions, okay? And then we can show the next event, okay, and all of the outcomes of that event that would follow all of the options of the first event. So in this example, we have a bag with 3 white and 4 red balls, and then we have a second bag with 2 white and 3 red balls. So we've got 2 different events, okay, and it doesn't necessarily matter in regards to whether they happen at the same time. We can treat them as one event happening and then those outcomes being recorded, and then the other event happening and those outcomes being recorded. Okay, so we can have our first bag, okay, and then our second bag results. And then if we need to, we can also write the sample space. Okay, SS just means sample space. Okay, so from the first bag, the options that we have is we could get a white ball or a red ball. Okay, they're the only options that we could get. Now, the probabilities of getting a white ball and a red ball are different. So what we do is we write those probabilities on the line or just above the line or below the line of that branch that goes into that direction. So the probability of getting a white ball, okay, there's 3 white balls and there's 7 balls in total. So it's 3 out of 7. Okay, the probability of getting a red ball is going to be 4 out of 7. Okay, so for the first bag, we show the 2 outcomes branching off, and then we write the probabilities next to the lines that we've drawn for those outcomes. For the second bag, we also can get a white ball or a red ball. And what we do is we show these 2 outcomes, but branching from the different outcome of the first bag. Okay, and then we can write the probabilities for that second event. So in the second bag, we have 5 in total, and 2 of them are white. So 2/5 is our probability of drawing a white ball. And then 3/5 for getting a red, and then it's the same down here, 2/5 and then 3/5. Okay, so our sample space then is going to be, we could get a white and a white, we could get a white then a red, or we could get a red then a white, and then we could get a red then a red. Okay, now the probabilities of these different events are basically when you have 2 events happening one after the other, you multiply their probabilities to get the probability of them both happening. And so what we have to do is we have to follow the sort of trajectory along that the probability tree that gets us to the outcome that we're looking for. So for 2 whites, it's going to be 3. Okay, the probability of getting 2 whites is going to be 3/7 times 2/5, which gives us 6 out of 35. Okay, you can use a calculator for that when needed. Okay, and then the probability of getting a white then a red, we follow that path, and it's going to be 3/7 times 2/5. Okay, which gives us times 3/5, which gives us 9 out of 35. Okay, the probability of getting a red then a white is going to be 4/7 times 2/5, which gives us 8 out of 35. And then the probability of getting the red and then a red. Sorry, it's going to be 4/7 times 3/5, which is going to be 12 out of 35. Now, you can actually know that you've done this correctly when all of these probabilities add up to 35. So you've got 6 plus 9 is 15, okay? And you got 8 plus 12 is 20. So add them all up, you get 35. So you know you've accounted for every outcome when that happens. So that's basically how to use a probability tree. Now, you wouldn't necessarily need to do all of this working when you're answering this question, but it's just to help you to understand how you would go about the process of whatever they could ask you. So the probability of getting 2 white balls, we know is 6 out of 35. Okay, the probability of getting 2 red balls is 12 out of 35. Okay, a white and a red ball in that order is going to be 9 out of 35. Okay, a white and a red ball in any order. Now, this is when we need to recognize that if there are multiple paths or multiple things in our sample space that fulfill the criteria, then we have to add those together. Okay, so for part D, both of these outcomes here satisfy a white and a red ball in any order. Okay, so then the probability is going to be 9 out of 35 plus 8 out of 35 because both of them work. So we end up with 17 out of 35 as our answer. And then at least 1 white ball. Okay, now when we're doing a question like this, it's actually easier to use the complement. So we've got to remember the complement is the opposite of something happening. And the way the complement works is it's the same as the probability of 1 minus that opposite happening. Okay, so the probability of at least 1 white ball is going to be the same as the 1 minus no white balls. Okay, and no white balls is just getting 2 reds. So that's going to be 1 minus 12 out of 35. And that gives us the answer. What's that going to be? 23 out of 35. Okay, now the other way you could do it is you could add up all the other ones together and you get the same answer. So 6 plus 9 plus 8 gives us 23 out of 35 as well. So you can add up all the options that contain a white ball, or you can do 1 minus the option that has no white balls. Okay, now just finishing off with this question. We've got to look at whether or not the outcome of the first thing affects the second thing. So when the first event does not affect the second, they're independent. And when the first event does affect the second event, we call these dependent events. Okay, so for part A here, we've got novels and maths books. For the first part, we're taking a book and then we put it back and then we randomly take a second book. Okay, what that means is the second book, it won't be affected by whatever we take first because we're putting it back on the shelf. So when we're doing our probability tree, we can get a novel or a maths book, okay? And then the second one can be a novel or a maths book. Novel and maths book as well. So there are outcomes. The probability, okay, 15 out of 23, and then 8 out of 23. And then it's going to be the same here. And then 8 out of 23, 15 out of 23, 8 out of 23. Now, I'm not going to go through the entire question here, but the process will be very similar. So then to calculate the probability of a novel than a maths book, okay, then it's going to be 15 over 23 times 8 out of 23, similar to what we did just above. And you could go through the same process. At least 1 maths book, you could do the one where you get 2 novels, okay, and do 1 minus the probability of 2 novels and you get there. For part B though, we're not replacing the book. So the outcomes are the same. We could get a novel or a maths book, a novel or a maths book. And then the probability of the first one is going to be the same. Okay, 8 out of 23. But once we've taken that book away, it's no longer available to be selected as the second book. So what's going to happen is the outcome of the second event will change depending on the outcome of the first event. So if we took a novel first, then there's only going to be 14 out of 22 left. If we took a novel first, then there's still going to be 8 maths books, but it's going to be out of 22. If we took a maths book first, then there's still going to be 15 novels there out of 22. And if we took a maths book first, then there would only be 7 maths books left over. Okay. And then again, you would do the same process of multiplying the different probabilities to get your answer. Okay. Hopefully this video helped. Good luck with the question today, and I'll catch you later.